Our next type of functions are polynomial and rational functions. So first, let's take a quick step back and quickly review what we know about quadratic functions. We know quadratic function comes in this form, ax squared plus bx plus c, and the graph is either a concave or convex parabola. Diving in deeper, in our function we see that we have three terms, where the exponents of x are decreasing from 2 to 1 to none. We also have numerical coefficients, where the last term is just a constant value. Now, what if we don't want to limit ourselves just to the power of 2? That is where polynomial functions come in. A polynomial is a function in this form, over here, and with variable x with decreasing exponent powers, as well as numerical coefficients and a constant. The number n over here, which is the largest power, is what we call the degree of the equation, and it can be any non-negative number. So for example, this function is a polynomial of degree 5, since that is the largest power. And here's its graph. We can see that it crosses the x-axis multiple times. And so for any polynomial, the degree is the same as the maximum number of times it may cross the x-axis, or the maximum number of roots that it may have. Another type of function are rational functions. So a rational function is the quotient of two polynomials, or in other words, when we divide a polynomial by another. Note that the denominator cannot be 0 over here, so q here can't be 0, and its degree needs to be at least 1. Otherwise, there would be no variable at the bottom. So this is an example of the graph of a rational function. A special feature of the graphs of rational functions are these lines called asymptotes. Okay? Since we cannot divide by 0, at any place where the denominator is 0, we have these lines where the function would approach these lines, but never actually reach. So let's try and sketch a rational function ourselves. Here we have our function 4 over x squared minus 4. So let's start off by finding these asymptotes we just talked about. So for these asymptotes, that's when the denominator is equal to 0. So doing a quick solve for this situation, we see that x is equal to plus or minus 2. So let's draw that out. So let's say here's my graph. Let's say here is minus 2, and here's 2. Next, let's go ahead and find the y-intercept. So the y-intercept is when x is equal to 0, which in our case is just at minus 1. So I'm going to go ahead and find minus 1 over here. For the x-intercept, this is when the function is equal to 0. However, since we have a constant at the top, this will never actually happen. So there is actually no x-intercept for this graph. Okay, and then now let's go ahead and figure out what's actually happening in these three sections. So our graph we see has three main sections: the middle section, and then the section where x is less than minus 2, and the section where x is greater than 2. Now for the non-middle sections, so for when x is less than minus 2, and when x is greater than 2, we can see that x squared minus 4 is positive. Okay? Right? Because and then if it's positive, that means the whole function would be positive. So over here we can see that we'll go in the positive realm for these two equations. Meanwhile, if x is between minus 2 and 2, we can see that this would be negative. And so Since negative, it'll be over down here and cross where the cross at -1. And so now we have graphed this function. Okay. And so that is a basic introduction to polynomial and rational functions.